Hey guys, in this video we're going to be talking about this F4 flight controller, and this is from Banggood, and this is a clone of the Omnibus F4 flight controller. So I'm going to refer to it as the Omnibus F4 for the duration of this video. Basically, it's an exact copy of the Omnibus F4 with all the same pinouts and the same features. I did a video a little while ago on this guy. This is the Omnibus F3 flight controller, and these guys both share the same set of features, with the exception of the Omnibus F3 has an F3 F3 processor, and the F4 has an F4 processor. As you can see here, the size of the chips are different. And additionally, on the back, we have a Blackbox SD card here, or SD card slot, so you can put in a micro SD card for your Blackbox on the Omnibus F3. That doesn't exist on the Omnibus F4, and instead you have this chip here. I think this is just for 16 megabytes of Blackbox data, so it's quite a bit less than what you can do on the F3 version. And the same OSD chip is on both of these. That's the Betaflight OSD, so it's got a direct connection. I think it's over a DMA connection, so that you can configure the OSD in Betaflight Configurator instead of using the old way, using a separate interface or UART to flash the and configure the OSD. So I'm going to go put this to the side. Now, why would you want this type of a board? And I've been kind of getting a lot of these lately in my builds, and I did put the F3 Omnibus in my GB130 that I just recently built here. You can see there is the board right there. And the reason that I'm selecting these boards is for a couple of reasons. They have the built-in Betaflight OSD, which is kind of nice and easy to set up and use, and has Blackbox, and it has a built-in 5-volt regulator so that you can supply direct battery voltage to the flight controller. And the reason I like that is because I'm starting to use a lot more of these 4-in-1 ESCs that don't have a 5-volt BEC, and I'm supplying direct battery voltage to these flight controllers. And some of these 4-in-1 ESCs don't have a BEC, so I have to do that. Now, here's just an example of a 4-in-1 ESC here. This particular one happens to have a 5-volt BEC on there. The version that is on here is the older version that does not have the 5-volt BEC. So having these flight controllers with a built-in regulator does give you a little bit more flexibility in terms of what kinds of components you can get, in addition to the all the great features that the board has. So let's take a look at the board itself. You got a Spectrum satellite port here. You got your boot button, USB connection. There's the F4 chip itself, and as you can see on this side of the board, there's nothing labeled as to what all these pins are. And by the way, there's no manual on the product page for this flight controller at the time of this filming. So I'm going off of the pinout diagram from the actual real Omnibus F4, and I'm assuming that it's going to be exactly the same. I'm going to actually test some of these with a multimeter to make sure that the pinouts are correct. Here's the back of the board with all of the things labeled. So let me highlight some of the more important things here. So on this on the left here, on this top row, we have ground, 5-volt, and S-bus or PPM, and this pin here. And if you go into the Betaflight configurator and switch the receiver output from PPM to S-bus, it'll enable this to S-bus, or you can switch it back to PPM. If you enable this on S-bus, then this will take up one of your UARTs, and I believe it's this pin is UART 1. And so if you enable S-bus over here for your receiver, then over here on this side, the TX1 and RX1 here as to transmit and receive of UART1 on this side will become disabled. And the rest of these pins On this side of the chip here are for your ESC motor wires, or your signal wires. So motor 1, motor 2, motor 3, and motor 4. Let's see, what else you got on this side? You got an OSD chip over here. I think this is the 5-volt regulator, and this is the 16 megabytes of Blackbox data. Okay, so in order to properly power this board and also provide power to your camera and video transmitter, let me go over how this board is pinned out. You're going to power your board on, let's see here, 1, 2, 3. This pin right here, this third pin down on the right, it's called the VBAT, and there's ground. You want to supply direct battery voltage to that from your PDB and not through a regulated source like a 12 volt or 5 volt regulator, because it's not only going to power this board, it's also going to provide voltage information to your OSD as to what your battery voltage is, and also setting your alarms and such like that. So you want to make sure you have direct battery voltage to that pin. And then the pin over here to the left of the VBAT is called VOSD. And this pin here is electrically the same as the pin, these two pins here in the middle. And these two rows of pins here are for your camera, for video in, and the bottom one here is for video out. That goes to your video transmitter. So I think the most typical way to wire this up would be to supply battery voltage to this pin here and ground, and then bridge the VBAT to the VOSD, so you get also direct battery voltage to these two pins here that will supply power to your video transmitter and your camera. The other way you could do that, by the way, the VBAT pin over here, it says VBAT, is electrically the same as the VBAT pin down here on the bottom row to the right. It says VBAT. The other way that you could actually wire this is, instead of providing battery voltage to the VOSD, you could provide 5 volts to the VOSD, and then you'll get 5 volts out over here instead of direct battery voltage. So you'd have to solder up a wire from one of these 5 volt pins to the VOSD, and then 5 volts will come out over here. Now, if you don't want to use the VBAT or the 5 volts to power your camera and video transmitter, you could, for example, some video transmitters, obviously you can get direct power from the battery to your video transmitter, and then some of those video transmitters will have power out to the camera, and if that's the case, then you can then use the video transmitter to provide power to this pin, and then that would then provide power to the camera. What you don't want to do is you don't want to have power coming in from the video transmitter and also coming in from this board through this VOSD pin being bridged to either the 5 volts or the VBAT. Then you're probably going to get something fried at that point with power coming from two different sources, so don't do that. Anyway, so that's just a brief overview of how to do the wiring on this. I'm going to go into the computer and I'll show you guys how this is set up in Betaflight. It uses the Omnibus F3 hex file, and as far as I know, it isn't all that different from the Omnibus F3 in the way it's set up, but we'll take a quick look at that, and also how the Betaflight OSD is also set up there as well. So let's go to the computer right now. Okay, let's take a look at what the board looks like in Betaflight Configurator. Comes with Betaflight 3.0.1. The board hex is Omnibus F3. And currently it only has UART 3 and 6 enabled. That's because I believe the receiver is set up for PPM. We can check that in the next tab here in configuration. And yeah, that's what I thought. So we'll have to switch this from PPM to serial here. And since I'm going to connect a FlySky X6B receiver to this board, I'm going to switch this to iBus for the serial receiver provider, and I'll reboot and reconnect, and I believe now, here we go, now we have UARTs 1, 3, and 6. So I believe that, as I mentioned before, that pin for PPM and SBus is for UART 1. So in order to enable that for the serial receiver, we have to turn off MSP and turn on serial RX and reboot. didn't save. It reverted back. Let's change this to serial RX again. Sometimes that happens, it'll revert back, and I'm not exactly sure why, so let me try it and see what's going on here. Okay, so now that change held, so I think you have to do it twice. You have to change it from ppm to serial RX so that you can get to this enable this UART1 on the ports tab, and then you got to enable serial RX again, and then it's going to go back to ppm, and then you have to go back there in configuration and change this from ppm to serial RX one more time for all the changes to hold. It looks like everything is holding now, so we should be good to go there. Failsafe, it looks like it's stock settings. Same with the PID tab, and I don't have a receiver connected to there, so there's nothing going on there. Nothing in the mode. So I believe everything else is just a stock flash, so you'll have to obviously make all of the changes according to whatever build you have. So let me show you guys the OSD. This is the main reason I like the Omnibus F3 and F4 is this built-in OSD, so that you don't have to mess with multi-Wii OSD anymore, and the other, Arduino and all that garbage is just all configurable right here in Betaflight Configurator. So it looks like I've already gone through here and turned off all the junk that I don't like, but as you can see here on the left, these are all the things that you could enable. I personally only like battery voltage and flight time on my screen and as far away from the center as possible, so that it's not in my line of sight and distracting me, and I'll only look at that usually when my timer goes off. So I set a timer on my transmitter, it beeps, then I'll glance down at the OSD to see what my voltage and my flight time is at, and it'll give me an indication of how much more flight time I have, if any, and when I need to land. So I use those two things. At least personally, that's how I use these things to manage my battery, so I don't fall out of the sky and crash into people. Bad stuff like that will happen. Take a look at the Blackbox tab here, and as you can see here, we have over here on the top it says data flash free 16 megabytes, and we should change this from serial port to onboard data flash chip and reboot this. Go back and reconnect, and yeah, so change this to the data flash chip, and then you probably want, because 16 megabytes really isn't a whole lot, you probably want to reduce your logging rate to say 33% or 25%, something like that. And that should pretty much do it. I just wanted to show you, a basic look at the board. It looks pretty much the same as the F3 board. Obviously, the biggest difference is this has an F4 CPU, and as you can see down here, the CPU load is really low. It's like 3%. I think in the way it's configured, let me just look here. It's like a 8 kilohertz, 2 kilohertz. Normally the CPU load would be around 20% on an F3 board, and it's going to be very low on an F4 board because it's got a lot more CPU cycles to spare. Anyway guys, that's a quick look at the Omnibus F4 flight controller. It's a pretty cool board. I like it. I'm probably going to get some more of these and use them in a lot more future builds. And let me know if you guys have any questions in the comment section below. I'll try and help you out as much as I can. And I hope you guys liked the video. If you did, please give me a thumbs up, and I'll talk to you guys in the next video.